Good morning, friends. I welcome you all to our C classroom. So, this is the lecture 4 on functions. In the last 3 lectures on functions, we have discussed different concepts about the functions. In lecture 1, we have discussed how to implement the functions in C language. What are the things need to be defined to implement the functions in C were thoroughly discussed in lecture 1. In lecture 2, we discussed how to pass variables of primary data type as an argument to the functions and how to pass pointers as an argument to the functions and what are the differences between call by value and call by reference. So these are covered in lecture 2 on functions. And in lecture 3, we discussed how to pass one-dimensional arrays as argument to the functions and how to pass two-dimensional arrays and strings as an argument to the functions were discussed in lecture 3. And this is lecture 4 on functions. In this lecture, we discuss how to pass structures as an argument to the functions. And then we will discuss how to define a pointer to the functions. And then we will discuss how to pass a function as an argument to the another function. Then I will give some programs for your practice. You can do those programs on your computer for getting the confidence on functions. And then we will look into some important questions related to today's class. Now we will proceed with the first concept called passing structures as an argument to the functions. See, till now we have passed variables of primary data type as an argument to the functions. We have passed arrays as argument to the functions. We have passed strings as an argument to the functions. And structures can also be passed as argument to the functions. To pass structures as an argument to the functions, we have two methods. One is you can send a copy of the structure to the called function as an argument. And second method is the address of the structure can be passed as an argument to the called function. So you can follow any one of these two methods, but each method is having its own advantages and disadvantages. To pass these structures as an argument to the called functions, the called function header and its declaration must be done properly. This is very, very important. Now let us see the first concept, passing a copy of structure as an argument to the function. So for this, the calling function must make a call to the called function using proper arguments. The arguments used by the calling function are called actual arguments. Calling function, when it is making a call to the called function, it should pass appropriate arguments to the called function. Since here our aim is to pass structure as an argument, a copy of structure as an argument to the called function. So we have to send the copy of the structure variable in the function call to the called function. Then what is the syntax that is to be followed in the calling function to call a called function? So for that, the syntax is like this. The called function name we have to write, and then name of the structure variable, which is whose copy is to be passed as an argument to the called function. So that structure variable name we have to send as an argument. Example, let just see update std. What is this update? Update is nothing but it is the name of the called function. And then what is this std? Std is nothing but it is the variable which is of type student structure. It is a student structure variable. So this variable name we have mentioned. Std is the name of the student structure variable. So its copy is sent to the update function. To receive this copy of structure variable, the update function header and its declaration must be done properly. Otherwise, compiler will generate an error. So how it is done? See, called function must be defined with suitable formal arguments in the function header. Called function header should be defined with the formal parameters. What are the formal parameters? One formal parameter should be used. What is that one formal parameter? So it must declare a structure variable of the suitable type. Whatever structure variable type is sent by the calling function to the called function, in the called function, the same type of structure should be declared. Its variable should be declared so that the copy of the structure variable, whatever is sent by the calling function, will be copied directly into the local variable of the called function. So for that purpose, the called function header should be declared suitable structure type variable. So the syntax for declaration of the function header, called function header, is like this. The return type of the called function and the called function name. See, the structure variable should be defined properly. Structure variable declaration starts with a keyword struct and yet followed by a tag name. Tag name is nothing but structure name and the variable name. So this variable name is used to copy the contents of the structure variable sent by the calling function. So that structure variable content is copied into this structure variable. Example, you can take struct student update and inside the parenthesis of update function struct student std. So here std is a variable which is of type student structure. Std is a variable which is of type student structure. Means whatever is sent by the calling function to the update function. So in the update function, that data, the member fields of the structure variable sent by the calling function will be copied into the member fields of the std structure variable. And then this update function is declared in its header that it is going to return a structure variable which is of type student structure. Update function here, it is declared to return a variable which is of type student structure. So this called function, it may return a value to the calling function or it may not return a value to the calling function. It is not necessary that the called function should return always some value to the calling function. It is not required. Now, how the function should be declared? Because the called function declaration should be done in the global declaration section. We know the declaration of the function means prototype declaration of the function is very similar to its header definition. The only difference is the prototype declaration is terminating with a semicolon and variable names in the prototype declaration are optional. Let us see the points written here. Called function must be declared with suitable formal arguments to the compiler like the function header. In whatever way the function header is written, in the same way the function declaration, prototype declaration or signature of the function should be done with a terminating semicolon. What are the arguments to be mentioned? Same, whatever argument you are mentioning in the header of the function definition, same header you can use here. So that header usually contains the structure type variable declaration. Same structure type variable declaration is also used in the function declaration. The syntax for declaring the called function prototype is like this: return type of the function and then followed by the function name and then structure variable name. Structure variable declaration is done with the keyword struct followed by the structure name. And this declaration is terminating with a semicolon at the end. And variable names are optional, we know, in the declaration. But in the definition, variable names are compulsory. In the declaration, variable names are optional. See one example here. Struct student update, same update function. In whatever way we wrote in the function header, in the same way we wrote here, but except with a semicolon. Function header doesn't have a semicolon, but prototype declaration is terminated with a semicolon. That is only the difference, and everything is same. And coming to most important point, when you are passing the copy of a structure as an argument to the called function, what happens? See here. When a structure variable is passed as an argument to the function, it passes only a copy of member fields of the structure variable to the called function. Hence, calling and called functions will work with different structure variables. Means when you are passing a structure variable as an argument to the called function, only a copy of that structure variable is sent to the called function. Means called function, whatever original copy of the structure variable it is having, it keeps original copy with it. It takes a Xerox copy and that Xerox copy is sent to the called function. So called function is having now a Xerox copy of the structure variable. Calling function is having the original copy of its structure variable. So in this case, the copies of the calling function and the called functions are different. So therefore, called function, since it is having only a copy of the structure variable of the calling function, if any member field values are modified by the called function, they are not going to be reflected in the calling function structure variable. That is most important. If any modifications are done by the called function to the member fields of the structure variable that it has received as an argument from the calling function, so these modifications will not be reflected in the calling function structure variable member fields. That is what you have to remember, because calling function is working with true copy, original copy, and called function is working with the Xerox copy. So they are both are different. So therefore, every function is having its own copy. So if any function modifies the member field values of the structure variable, they are not get reflected in other functions. So this is the most important point that we have to remember. So this is also called passing a copy of a variable to the called function is nothing but call by value or pass by value technique. Means here we are passing the structure variable using a technique called call by value or pass by value method. When pass by value or call by value method is used, the calling function will work with one copy and the called function will work with another copy of the variable. So if any one of these two functions modifies the values of the variables, they are not getting reflected in the other function. This is the most important thing we have to remember. Then let us go for one example program. What is this example program? It will demonstrate how a structure is passed as an argument to the function. Which method we are following in this program? We are following a method called call by value method. A copy of structure variable we are passing. A copy of structure variable is being passed to the called function, means it is call by value or pass by value method. See, the function update will update the member fields of the structure variable and prints those values. And the main function also prints the structure variable values, but they are different. Means here update function is receiving a structure variable as an argument from the main function. Main function first reads the member field values from the user, and then it makes a call to update function by sending the copy of the structure variable to the update function. Then update function getting executed, it modifies the member field values of the structure variable that it has received as an argument from the calling function, and then prints its values. Once this update function is terminated, then main function starts its execution. And in the main function also prints the values of same structure variable. But the values printed by the main function are different and values printed by the update function are different. Why? Means update function, whatever member field values it is updating, they are not get reflected in the structure variable of the main function, because update function will work with one copy of the structure variable and the main function is working with another copy of the structure variable. Let us see the program. Here we have defined a student structure, same old student structure that we have been using this in structures. Almost in all programs where we have used student structure, same member fields have been mentioned. So therefore there is no need for the explanation. The marks of the student scores in 6 subjects are stored in the variables S1 to S6. And once user gives the marks of the student and hall ticket number name, then we will calculate the total marks of the student and then percentage of the student. Here we are using one user defined function called update function. Update function, here it is declared to receive a structure variable as a argument, and this structure variable is of type student structure, and update function is declared that it is not returning any value to the calling function. So therefore its return type is void. Its return type is mentioned as void. Now let us see the main program. In the main program we have created a student structure variable called std. Then we are asking the user to read the value, hall ticket number and the name of the student, and these values we are storing in appropriate member fields of the std student structure variable. And then we are asking the user to enter the marks scores of the student in 6 subjects in a row. All these marks we are reading and storing in S1, S2, S3 up to S6 member fields of the structure variable std. And then once marks are known to us, then we are calculating the total marks of the student and then percentage of the student. Then here we are making a call to update function by passing this student structure variable std as an argument to the update function. Then the main function program is stopped here, and control from this statement it is passed to the update function. See the update function. Update function, it is receiving the student structure variable std. The copy of std student structure variable is being received as an argument, and that the values are copied into the variable s. S is also same structure variable. It is also student structure variable. So whatever copy of values are sent by the calling function of the student structure variable std, those values are copied into the here structure variable s. Now what this update function is doing is, update function is updating the marks of the student in 3 subjects. In S1 subject marks it is adding 10 marks, S2 subject marks it is also adding 10 marks. Here S3 subject marks, it is adding 10 more marks. So this statement, third statement, S dot S2. So this statement should be written as S dot S3 is equal to S dot S3 plus 10. So this is written wrongly here. So this is the third statement is S dot S3 is equal to S dot S3 plus 10. Means update function is updating the marks of the student in 3 subjects by adding 10 marks in the first 3 subjects. Since the marks are changed, the total will also change. So therefore we are again calculating the total in the update function. And then we are calculating, since total is changing, student percentage will change. Percentage is being calculated. And after updating the marks in 3 subjects, update function is displaying the details of the marks scores of the student. It's his student hall ticket number, student name, and then the marks scores in 6 subjects along with total marks and percentage it is displayed. And after displaying the updated marks, the update function is going to terminate by passing the control back to the main function. So now let us come to the main function. The main function execution has stopped at this statement. So now when control comes back to the main function resumes its execution and start executing the statements in the main function. The statements after this update statement are, these are the statements. Again, the main function is also displaying the marks scores of the student in all 6 subjects along with the total marks and then percentage. See here, first the main function after reading the values from the user and it is calculating total marks and percentage of the student. Then it is making a call to the update function. Now the update function is updating the marks of the student and displaying the complete details of the marks scores of the student. And then after displaying the marks scores of the student, it is sending back the control to the main function. And main function is also displaying the student details. Now the student details displayed by the update function are different from the student marks scores displayed by the main function, because update function has modified the 3 subject marks. They are not getting reflected in the main function because main function has passed only the copy of a structure variable to the update function. So update function is working with one set of structure variable and then main function is working with the other set of structure variable. Hence the modifications done by the update function are not getting reflected in the main function. Because of this reason, the mark scores printed by the main function are different from the mark scores printed by the update function. So this is the best example for pass by value or call by value technique, through which we have passed structure as the argument. Let us come to the second technique, that is passing address of the structure as an argument to the function. Here also to pass the address of the structure variable. Address of the structure variable means what we are doing here is, because a structure variable occupies some space in the memory, directly that address of that structure variable we are passing as an argument to the called function. The called function receives that address and directly goes to that address location in the memory and modifies the values. Means called function and calling function both are working with the original copy of the structure variable where it is stored in the memory. Calling function simply giving the address of that structure variable where it is available in the memory. That address is being received by the called function and the called function directly going to that address location in the main memory and modifying the values of the structure member fields. And the same member field values are accessed both by the called function and the calling function. So therefore in this case, if calling or called function modifies the values of the member fields of the structure variable, they are definitely getting reflected in the other function. Let us see for this case how we have to declare the called function header and its declaration, and how calling a function should make a call to the called function. First, let us see how calling function should make a call to the called function to pass the address of the structure variable as an argument to the called function. Calling function must make a call to the called function using proper actual arguments. So what are the arguments? The argument is nothing but the address of the structure variable should be passed as an argument to the function. The syntax for making the function call by the calling function to the called function is like this. The function call contains simply called function name and then ampersand. Ampersand always gives the address of the variable. So here what variable we are using? We are using a structure variable. Structure variable name we are writing here. The address of that structure variable is sent to the called function. Example, update structure of std. Std is nothing but here it is a student structure variable. The address of this student structure variable we are passing to the update function. Update function is the called function. Therefore, the update function header and its declaration must be done properly to receive the address of this student structure as an argument. Since we are passing address, definitely the update function must have a pointer declaration which can point out the addresses of the student structure variable. Proper pointer must be defined in the function header. Let us see. Called function must be defined with suitable formal arguments in the function header. And what is that formal arguments to be defined in the called function? That is nothing but a pointer to the structure variable should be declared. Appropriate pointer which can point out the addresses of the student structure should be defined properly. The syntax for called function header is like this. Return type, function name, and structure variable name. Here star represent that this variable, structure variable, is nothing but it is not a normal variable. It is a pointer which can point out the addresses of the variables which are of type this structure. Tag name means structure name. Whatever structure name you write here, this pointer will point out the addresses of that type of structure variables. Example, void object struct student star ps. Update function, again we have used. It is a called function and it is returning nothing to the calling function. And what it is, what type of arguments it is receiving? It is receiving an address. To store that address, it must have a suitable pointer. What is that pointer? PS. PS means star PS. Star represents that it is a PS is a not normal variable. It is a pointer variable. Star represents that it is a pointer. PS is a pointer. PS I used because I am keeping an abbreviation to the PS that pointer to a structure. PS. PS is a pointer to the structure, means it point out the addresses of the structure variables of type student structure. That is the meaning of this example. Now, how to declare the function? Called function declaration, prototype declaration. We know the prototype declaration is very similar to the function header, except that it is terminated with a semicolon. Called function must be declared with suitable formal arguments to the compiler, like the function header. So what formal arguments we have to use here? A pointer to the structure type. Same, whatever is discussed in the function header, same thing we have to use here. Syntax for called function prototype declaration is like this. Return type and a called function name, struct, tag name means structure name, and a pointer name. What type of pointer, what name you use to the pointer, that pointer name. Pointer name should be preceded with a star. If you use star, then only compiler considers it as a pointer. Otherwise, it is treated as a normal variable. And the declaration should terminate with a semicolon. You know, in the declaration, the variable name is optional. If you want, you use it. Otherwise, don't use it. Example, void update struct student. Same, whatever we discussed in the function header, same thing, except that it is having a semicolon here. Then coming to the most important point here. Read this line. When the address of the structure variable is passed as an argument to the function, called function directly point out the structure variable stored in the memory. Hence, calling and called functions will work with the same structure variable. So therefore, if called function modifies the values of the structure variable, then it will be reflected in the structure variable of the calling function, because both are working with the only one copy of the structure variable. Called function is passing the address of the structure variable, and called function is receiving that address, whatever is sent by the calling function. Calling function is sending the address of the structure variable where it is available in the memory. That address of the structure variable is sent as an argument to the called function. Called function uses that address and directly going to the memory location, and there it is modifying the member field values of that structure variable. And same structure variable is used by the called function and also calling function. So therefore, called function, if it modifies the member field values of that structure variable, then automatically the calling function make use of that modified values. So therefore, they are reflected in the calling function values. That is the most important point. Let us see the same program that we wrote using pass by value, passing structure as a argument to the function using pass by value. Same example we will see here. Same structure variable now we will pass by its address. So this technique is called pass by pointer or pass by address technique, because we are passing address. Address means pointer, so therefore it is also called pass by pointer or pass by address, and it is also called pass by reference, or it is called call by pointer, call by address, or call by reference. Let us see. Same structure we have used student structure with the 6 subjects, scores, and then total marks and percentage, along with student hall ticket number and name. We have used update function same. But here the update function is declared to receive the address of a structure variables. That address is assigned to PS pointer. PS is a pointer which is declared to point out the addresses of the variables of type student structure. And this update function will work with the values of the structure student structure variables, but it doesn't return any value to the calling function. So therefore its return type is mentioned as void. See main function. In the main function, we have created a structure variable std. And then we are asking the user to enter student hall ticket number and name, that we are storing in appropriate member fields. And then we are asking the user to enter marks scores of the student in 6 subjects. And they are also we are storing in appropriate member fields S1 to S6. Then once marks are known to us, we are calculating the total marks of the student. And from the total marks, we have calculated the percentage. Now we are making a call to update function. See, I wrote with the red ink, because this is the difference that you have to find from the previous program and this program. Here we are passing the address of student structure. In the previous case, simply we wrote update inside the parenthesis std. But here the variable name, structure variable name std is preceded with an ampersand. Ampersand means it gives the address of structure variable. Now the control is transferred from the main program to the update program. Main program is temporarily suspended for its execution till this update function finishes its execution. When update function finishes its execution, then control comes back to the main function. So now we will jump to the update function. See how that update function is defined. Update function. So update function here, it is already declared in the global declaration section that it is receiving the address. To receive that address, it must have a pointer. So pointer we have defined here. PS is a pointer which point out the addresses of the variables of student structure. We have passed the address of the STD structure. That address of STD structure variable is pointed out by this PS. Since now PS is a pointer to a structure variable, all the member fields of that structure variable will be accessible to the PS pointer. And when you are having a pointer to a structure variable, the member fields of the structure variable are accessed using a arrow operator. See how this PS is updating the values of the member fields of the structure variable STD. PS arrow mark S1. Arrow mark S1 means it is accessing the member field S1 in the STD student structure. And to that it is adding marks 10. And then it is adding 10 marks to the subject 2. Similarly, this statement should be written as PSS3 equal to PSS3 plus 10. So it is updating here the third subject marks. It is updating by adding 10 marks to the existing marks. Since these marks are being updated directly in the memory location where STD student structure variable is stored, directly there it is being updated. And after updating, again it is calculating the total marks again in the same structure variable, and then it is calculating the new percentage. Because marks are updated, total marks will change. Once total is changing, automatically percentage will also change. Then it is not displaying any value, any details of the student. Simply it is transferring the control back to the main program. And in the main program, controls comes to this statement. And from there it starts executing. What are the next statements that are there in the main program? In the main program, it is displaying the details of the students. And if you see, when this output is displayed on the screen, the marks entered by the user in first 3 subjects will be different from the marks displayed on the screen. Because in first 3 subjects, the update function has updated the student marks by adding 10 more marks in the first 3 subjects. So therefore, you will get in first 3 subjects 10 more marks extra than the marks given by the user. Means called function, when it is updating the value of the variable, then those values are getting reflected in the main program. Because the calling function, main function, and the called function, update function, both are working with the same copy by directly pointing out the location of the structure variable stored in the memory. So since address we have passed in this program, structure variable address we have passed in the program, this method of passing structure variable as an argument to the function is called pass by pointer, or pass by address, or pass by reference, or call by pointer, call by address, or call by reference. So these 6 names are reflecting the same concept. So this is about how to pass structures as an argument to the functions. Now, let us see the second concept. The second concept is defining a pointer to a function. How do we define a pointer to a function? A function is very similar to a primary data type variable, that we know. Since a function is very similar to a variable of primary data type, to the variables of primary data type we can define a pointer. Similarly, to a function also we can define a pointer, because the properties of variable and function are same. Both variables and functions are having name. They are associated with some name. And then both variable and functions, they are associated with the data type. Variables are declared as int x or float y, like that we are defining. Similarly, function is also having some associated with some data type. The data type of the function is called a return type. Means every function returns some value. If the function is not returning any value, then its return type will be mentioned as void. Then every variable is associated with a memory address. Similarly, the function is also associated with the memory address, because when you declare a variable of primary data type, immediately compiler allocates some space in the computer memory to store that variable name. Similarly, when you define a function, when you declare a function, automatically compiler will allocate some space in the computer memory to store the function data and the function statements, instructions of that function. Means function is also associated with some memory. Variable is also associated with the memory. When you declare a pointer, pointer will point out the address of the variable. Similarly, when you declare a pointer to a function, pointer will point out the first instruction of the function. That is nothing but function address. See, a pointer can be made to a function because a function is also associated with the address. Syntax to declare a pointer to a function is like this: return type of the function, and then a pointer star, pointer name, then parenthesis, set of parentheses. And this pointer name is declared with a star. Star represents that it is a pointer. And this parenthesis around the pointer are mandatory, because if you do not use that parenthesis around the pointer name, then it simply tells that it is a function name that returns a pointer. Here we are not talking about the function which are returning pointers. We are talking about the pointer to a function. So here this syntax tells that it is a pointer to a function. This empty parenthesis tells that it is a pointer. Star tells that it is a pointer. And parenthesis tells that this pointer is to a function. And return type tells that this pointer will point out the functions which are returning this type of data type. Example, see here, you will understand. Double star PF and then opening a set of empty parentheses. PF name is preceded with a star, so it tells that PF is a pointer. This empty set of parentheses tells that pointer, this PF is a pointer which point out the functions. Empty set of parentheses tells that it is a pointer to a function. And which type of functions it will point out? It will point out the addresses of the functions which returns double values. Which returns double values to the calling function. That is the meaning of the function. Now, we know that function name always acts as a constant pointer to the first instruction of the function. It is very similar to the array. Array name is also acting as a constant pointer to the first element in the array. Similarly, the function name also acts as a constant pointer to the first instruction of the function. Means the function name represents the address location of the first instruction of the function in the memory. So, if you want to make the pointer to point out that function, you should know the function address. The address of the first instruction of the function should be known to us. How do we know the address of the first instruction of the function? The function name itself is giving the address of the first instruction, because the function name is a constant pointer to the address of the first instruction. So therefore, if you wanted to make the pointer to point out any function, what you have to do is simply you assign a function name to the pointer. Pointer is equal to function name. Means this function name is acting as a pointer to the first instruction of this function. That address is assigned to this PTR, where PTR is declared such that it is a pointer to the function. Then only this statement is valid. Because function name you are giving, to receive this function address, the pointer should be declared properly that it will point out the addresses of the functions of this type. Then only it is valid. Otherwise, it is not valid. Let us see one example. Suppose you are having a function mul, which receives two arguments, integer values from the calling function, and it returns a double value back to the calling function. Then if you have any pointer here, in the previous slide we declared a pointer pf, which point out the addresses of the functions that can return double value. Here mul function is declared that it is returning a double value. So therefore mul function address can be assigned to this pf pointer. You can write that pf pointer is equal to mul. Mul is giving the address of its first instruction to the pointer. Now the ptr pointer is pointing out the address of the first instruction of the mul function. Means ptr is accessing the address of the first instruction of the mul function. And ptr should be declared like this: double star pf, like pf. There you have to write, instead of pf, ptr and empty set of parentheses. Then this statement is valid. Otherwise this statement is not valid. Now we know how to declare a pointer to a function, and then how to make the pointer to point out the function, and then we have to see how to call the function using this pointer, because pointer is pointing out the function. So function can be called, its instruction can be accessible using a pointer. So therefore how can we make a call to that function through the pointer? So for that syntax is like this: star ptr, simply if any arguments are received by that function, that argument values v1, v2, v3, v4, v5 and so on, that arguments list you have to pass. It is simply making a function call. See, c is equal to star ptr a comma b, means you are making a call to a function with two arguments a comma b, and this function returns some value, that value you are assigning to c. This statement is equivalent to, because you have made ptr to point out mul function. Mul function is receiving two arguments, a and b values, integer arguments. So here integer arguments you are passing two values, a and b, to the mul function. And mul function is declared that it returns double value, that whatever double value it is returning, mul function you are storing in c. Writing this statement is equal to writing c is equal to mul a comma b, because mul function is receiving ab and mul function returns some double value, that double value you are storing in c. Instead of mul, here we made pointer, because you have made pointer to point out mul function. So since ptr is pointing out mul function, you can make a call to the mul function by writing a statement like this. Both statements are same. You are calling mul function through the pointer ptr. Let us see a simple program. Here we have declared mul function, that it is receiving two integer arguments a and b, and it returns an integer value to the calling function. Then here we have declared a pointer pf. Pf means pointer to a function. Star represents that it is a pointer. Empty set of parentheses represent that it is a pointer to the function. And this integer type tells that this pointer pf point out the functions which can return integer values. Mul function is declared to return integer values. So therefore mul function address we can assign to the pf. We have assigned mul function address to pf. Now pf is made to point out to mul function. In the main program, see, we have declared three variables of integer type x, y, z. We are reading the values of two integer variables and storing in variable x and y. And then we are making a call to mul function by using pf. Through pf pointer, we are calling mul function by passing a and b values as argument. Mul function returns the product of mul, stands for multiplication. It multiplies a and b values and it will get some integer product. That product it returns. That value is stored in z. So whenever the statement is executed, since you are making a call to mul function, control is transferred to the mul function. Mul function receives ab values as argument from Here not AB, you have to write here x comma y because the variables are declared as x comma y. Star PF inside the parenthesis x comma y you have to write. Here A, B is wrong. X value is assigned to variable A and Y value is assigned to variable B. And these are multiplied and that will be returned. So this value is function is returning a product. That product is stored in variable Z. And now when control comes to the main function, variable Z contains the product of A and B. That product is displayed by the main function and the main function is terminated. Like that you can declare a pointer to a function and then you can call the function using that pointer. And then we will go to third concept called how do we pass function as an argument to another function. Till now we have passed variables, pointers as argument to the functions, and one-dimensional arrays, two-dimensional arrays, strings as argument to the functions, and structures as an argument to the functions. Now, how do we pass one function as an argument to the another function? It is very easy because we know that a pointer can point out the function. Through the pointers, you can pass one function as an argument to the other function. What we have to do is for this, first you declare a pointer to a function. Make that pointer to point out some function. And that pointer you can pass it as an argument to the another function. Or just pass the function name as an argument to the another function. In another function which is going to receive that function as an argument, you declare a pointer there which can point out the function. So like that you can pass a function as an argument to the another function. Let us see the statements, how it can be done. Since a function is associated with a memory address, it can be passed as an argument to the other function. Just now I told that function is associated with the memory address. You declare a pointer so that the function first instruction address is assigned to that pointer. The function name acts as a constant pointer to the address of the first instruction of the function in the memory. This also we have discussed just now. And then what is the third point? When a function is passed as an argument to the another function, the called function must declare a pointer to a function to receive that function address, both in function header and the function declaration. So this is compulsory. Because when you are passing one function as an argument to another function, in the another function, you must have a proper pointer which can point out the addresses of the function. Then only this function is received as argument by the called function. The called function, you must have a pointer. See, syntax to declare a pointer to a function in the function header. Same thing is there in the function declaration also. See, return type of the function, and this is the called function name, and then this is data type of the function, and then pointer name with empty set of parentheses. This is nothing but declaring a pointer to a function, same data type which we have discussed in the previous concept. PTR name means pointer name. Star indicates that it is not a normal variable, it is a pointer variable. Set of empty parentheses represent that it is a pointer to a function, and this data type represent that this pointer point out the functions which can return this data type. See example, white table. Table is one called function name, and inside that called function we have declared a pointer PF. PF is a pointer to a function because empty set of parentheses are there. Pointer to a function. It point out the addresses of the function which returns double values. PF point out the addresses of the functions which returns double values. Like that. Now, this table function, table is a called function which doesn't return any value to the calling function. Now, calling a function, how it should pass a function as argument to the other function. It is very simple. when it is making a call to the called function, if it calling function, if it wanted to pass a function as argument to the called function, simply when it is making a call, simply it can keep the function name which is to be passed as argument to the called function. That function name it has to mention. Example, table of y. Table is a called function. To this called function, calling function passing the address of a function y. Y is the name of some other function. So that y address it is passing. Simply it is mentioning the name. What this y represent? Y represent a function. Y is a function name, and that function name it is keeping it as an argument here. Function name is pointing out the address of first instruction of that function, means it is a pointer. So it is passing the address of first instruction of the function y. In the table called function, you must have a pointer there which can point out the addresses of the function. Otherwise, it is not valid. Let us see the example program. How a function is passed as an argument to the another function. Prototype declaration of equation function and table function. See, equation function. It receives one float type value as argument from the calling function. Then it returns a float value back to the calling function. Then table is another function which returns nothing to the calling function, but its first argument is pointer to a function. This PF point out the functions which returns float values. Here EQ returns float value. So therefore you can make PF to point out EQ function. Means EQ stands for equation. And along with this pointer to a function, table function is also receiving other three float arguments. Float, comma, float, comma, float. Three floats are mentioned. Means it receives three float values as argument along with the function address, which returns a float value. See, in the main function, we have printed an equation y of x is equal to 2x square minus x plus 5. This value we have to determine. Means we have to determine the value of y for each value of x. We are assuming that, see, we are calling to print this equation values for every value of x. The equation is y of x is equal to 2x square minus x plus 5. To print this equation value, we are making a call to table function. So in this equation, for each value of x, we have to calculate the y value, and y value should be printed for each value of x. Means it is a table of values. In the first column, x values will be there, and for each x value, what is its corresponding y value. That y value is mentioned in the second column. To print this table of values, x and y values, we are making a call to table function. Table, and in the table functions, carefully observe the arguments. The first argument is function name. What is that function name? EQ. EQ means you are passing a function as an argument to the table function. Table is a called function by the main function. Main function is calling table function. While it is making a call to table function, it is passing another function, EQ function, as an argument by mentioning that function name. And it is also passing three float values, other float values as argument. 0.0 is first float value, and then 10.0 is another float value. Third float value is 0.5. What is the significance of these three float values? We will see. Once this table function is called, main program is suspended for its execution temporarily, and the control is transferred to the table function. Let us see the table function, how it is defined. Table function, it is defined like this here. First argument, since we have to the table function, we have passed function name as an argument to the table function. So therefore we defined a pointer here, PF, which point out the addresses of the functions which returns float values as argument. Our EQ function is returning float value. So its address is assigned to PF function. And then three float values as argument we are sending. First float value is copied, means 0.0 is copied into min variable, and then second float value, that is 10. 10 is copied into max value, and third value 0.5 we mentioned here. This is copied into increment variable, inc, increment variable. Means we want to have the x value starting from 0.0 to up to maximum of 10.0. X values are changing from 0.2 to 0.0 to 10.0. So from 0.20 it will go up to 10.0 with an increments of 0.5. Means x value initially 0.0, next x value is 0.5, next x value is 1.0, next x value is 1.5, and the next x value is 2.0, and the next x value is 2.5, like that. X value is incremented by 0.5. For every value of x, we have to calculate y value. Using equation y of x is equal to x square minus x plus 5. So for calculating that, we have declared a float variable called value inside the table function, and then for I should also be declared here, value comma I, declare I, otherwise compiler generates an error. I forgot to declare variable I here. So what you have to do is write value comma I here. Then I value initially minimum. Minimum means 0.0. Then I is less than or equal to max. What is max value? 10.0. I value as long as it is less than or equal to 10.0. Now first initially I value is 0.0. It will check the condition. Condition is 0.0 is less than 10.0, true. So it is entering into the loop. Inside the loop we wrote value equal to star pf I. I value is now 0.0. We are making a call to pf function. Pf is nothing but pf is now pointing out the address of eq function. So indirectly we are making a call to eq function with a value 0.0 because initially I value is 0.0. Immediately control is transferred to eq function with the value 0.0, I value is 0.0, that is assigned to x. Then it calculating x value with 0.0, it is calculating 2x square minus x plus 5 value. Whatever value is obtained, it is being returned to this statement. So value will get that value. So normally it is value 5, and that value I value means x value. Present x value is 0.0, y value is 5, that is displayed. Once this statement is executed, again I value is incremented by 0.5. Previously it is 0, now it becomes 0.5. So 0.5 is less than 10.0. Again it is making a call to eq function with the I value as 0.5. That I value is copied into variable x, means x value is 0.5 now. Using x value 0.5, this value is calculated, and that value is assigned to value variable. Value variable means it is nothing but value of y. So I value 0.5 value, whatever is computed, that is printed here. Then I value is incremented. I value previously it is 0.5 plus 0.5 is getting added. So new value of I is 1.0. One condition is verified now. 1.0 is less than or equal to 10.0. It is true. Since it is true, it is entering into the body of the loop. Again, it is making a call to eq function with I value as 1.0. That I value 1.0 is copied into variable x with x value as 1.0. This equation is evaluated and it returns a value. That value is copied into value variable. Again, I value 1.0 and whatever value is obtained for value variable, that is displayed. After that, again I value is incremented by another 0.5. Previously I value is 1.0. Now 1.0 plus increment value is 0.5. 1.0 plus 0.5, it becomes 1.5 is the new value of I, and it verifies the condition. 1.5 is less than or equal to 10.0. So condition is true. So this goes on until I reaches 10.0. When I value becomes 10.5, so 10.5 is less than or equal to 10.0, it will be false. Then condition will be stopped. Then control is sent back to main program. From table it will comes back to the main function. In the main function, statement starts executing. So what statement is there after the call to the table function? Only printf. A line is printed, then main program is closed. So this is how we are passing EQ function as an argument to the table function. Table function is, while it is printing the table of values, it is making a call to EQ function through the pointer and getting the value 2x square minus x plus 5 value from the EQ function. And then coming to the exercise program. After looking at all these programs which we have discussed, you can write the programs for these things. Okay, so I have given how to pass one structure called item as an argument to the function. So first program is to be written using call by value method, pass by value method. Call by value or pass by value, both are same. And same program should be written using pointer to the structure. That is the second program. Means the same, whatever problem is mentioned in the question number 1, the same question is now solved using pointer to a structure as an argument. So these two programs you have to learn. And the how to define a pointer to a function and how to pass function as an argument to another function. Both concepts are important. And passing structures as an argument to the functions are also important. So these three concepts are asked many times in the examination. So therefore, carefully listen to this video lecture and then prepare your notes while listening to the video lecture. Note down important points, then read that notes carefully, and then read your textbook Balaguru Swami, 3rd edition, C and Data Structures by Balaguru Swami, 3rd edition. That textbook you have to read and then write the answers for these questions. 3 questions I am giving. How to pass the structures as an argument to the functions. Explain with suitable example. So this question was almost every time it is coming in the examination. We discussed how to pass structures as argument to the functions. Pass by a copy of structure is passed as an argument, or the address of the structure is passed as the argument. So these are 2 ways are there. Sending a copy of the structure. Second method is sending the address of the structure as an argument to the called function. Both techniques you discuss. If time is there, you can also write a program in the examination. But in the assignment, for each method you write a program also, so that you will be perfect. In the examination, since it was asked only for 5 marks, so therefore just write the method. There is no need to write the program, or at least you give the outlines of the program. No need to write every statement of the program, just function header, then inside the body important statements, then close the functions. Like that we have to write. Second question is how to declare a pointer to a function. We have discussed. Give the syntax and explain with a program. So if it is coming for 2 marks or 3 marks question, just tell how the pointer is to be declared to a function and how the function is called through the pointer and how the pointer is made to point out that function. These 3 steps you discuss for 2 or 3 marks questions. And if you same question if you get for 5 marks, also write the program and explain that program. This has also come many times in the examination, so it is also very important. Next one is how to pass function as an argument to the another function. So this program, this concept is a little bit confusing, but 2 or 3 times if you read with the patience, then automatically you will understand. But this question was till now it was not asked, but it is also important. Passing function as an argument to the another function. So these 3 questions, you have to write the answers for these questions. And in the last class, yesterday's class, I have given 1 more question. So total 4 questions. Prepare the answer for 4 questions and send the sheets to my email ID. Okay, soft copy of these answers you have to send it to me. So I request all the students to prepare well for C programming subject, because this subject is new to you. So unless you concentrate on this subject, it is very difficult for you to learn the concepts of the subject. And C is the basic thing for you, because if you are perfect with the C language, then in the second semester C++ and Java becomes easy. Whatever logic you learned here, the same logic you are going to use in C++ and Java. Only the syntax, the way you write the statements in C++ and Java will change. But the basic logic to solve the problem is the same. So therefore, I request all the students to carefully listen to my video lectures. And if you have any doubts, don't hesitate to make a call to me and to get the clarification to your doubts. Okay, so my cell number is known to you, 9848919656. You can call me on any working day between 9:30 a.m. and 5 p.m. I will be available to you. Thank you. Thank you all for your patience listening. Okay, thank you all.